All right, so we're going to pick up where we left off yesterday with these composition functions. We're on page 69. But before we get started with that, I wanted to just take a look at our kind of schedule for the unit. Okay, so if you can take a look at the chart title page for a second. Just want to highlight some things. Okay, you have this at your disposal, so hopefully you're checking this on a daily basis, just trying to see what's coming up. All right, so as a refresher, we are on day 22 today, so we're going to wrap up this composition section. And tomorrow and Friday, we're going to be dealing with what looks like our last section of the unit. Okay, so we're going to wrap up our first unit by the end of this week. Come next week, we're going to have another free response day in your groups, okay, where you have to work together and someone will present your free response question. We're going to have another partner quiz, a review day, and then we're going to have our unit test for this unit, okay? This one's a little different, the unit test, than the last one you took. You see how this one's a 2-dayer, where the last one was a 1-day? Okay. Is there anything for the office? Thank you. Have a good day. All right, so for this unit test, it's I'm going to spread it over 2 days, just to make sure we have enough time. Notice how on the first day, you're going to have 14 multiple choice questions. Okay, or letters A, B, C, or D, you got to figure out which one it is. And no calculator for that one. On the second day, okay, you're going to have 2 free response questions, kind of like the ones we go over on the free response day. Again, no calculator. Since we're going to be having our unit tests, I'm going to be collecting your homework from the unit. Okay, so make sure that you have those homework pages that are listed in that chart completed, because we know what happens, right, if we turn in all of our homework and it's completed. We remember? Do we need a refresher? No? Okay, so make sure you have your homework done on that first test day. Any questions about what's coming up next week? All right, so let's take a look at page 69. We were dealing with function composition yesterday, how we were using either tables or graphs or equations to help us compose or bring together or create new function values. We're going to amp it up a little bit today, and instead of looking at values, do you guys realize how yesterday we always kind of got a number as our answer? Not sure if you realize that or not. Okay, today we're going to move away from numbers and we're going to just work with equations. So we might have some variables that are left. It works the same way, but it looks a little different, so I want to make sure that we kind of understand what's going on here. So yesterday I think we finished 1, 2, and 3 at the top. Is that right? Okay, so we're going to pick up with the next section at the bottom. We're still using the 4 equations at the top. Okay, so we have that quadratic, the 2 linears, and then the rational. Let's go ahead and take a look at this first task that we have to do. Oh, actually, we're not using those same ones. Sorry, they tell us exactly what we're using here. If f of x is this quadratic and g of x is that linear, we want to figure out this composition. Notice how we're going to be bringing 2 values together. So can we dig deep from yesterday and think about what this notation is telling us to do? What do you think, Rebecca?
For the g function, if you plug in -2 for x, and then that value would equal the x for the f function.
It's your new input. Okay, so if we were to write that out, we're going to find g of 2. Then this value is the new input for the f of x equation. All right, so we kind of did these yesterday. Let's see if we can dig deep and do another one today. If you were to plug in -2 into the g equation, Looks like we got -3. So this -3 is the new input, okay, the new x value for the f equation. So let's go ahead and plug in -3 into the other equation we have. Okay, be careful, we got a lot of negatives, order of operations, you got to think about what comes first. Parentheses and exponents, so -3 squared would be 9. -3 times -3 would be another 9. So we have 18 plus 9 plus 2. Looks like we have 29. We didn't lose it from yesterday, did we? No. Good. Okay. So let's take a look at the second task. We still have the same two equations, okay, that we just used, the f and the g, but notice how what we're trying to find now is slightly different. F of g of x. Do you notice how we don't have that -2 anymore, or that number? Okay, so what do you think this notation is telling us to do? Go ahead, Ashlyn.
Equal both the equations to one another.
Not necessarily equal, because we don't really have an equal sign in there. If that was the case, it would be f of x equals f of g. That's when we would equal them together. Okay, but that's a really good guess. What do you think, Tori? Okay, so the same idea here. Notice how we had to plug in -2 into the g, but we don't really have a number to plug in this case. So we don't really have to do this step, okay? But we do still have the g equation inside the f. Can you see how that's written? Okay, so we're going to, how do we want to word this? We will put the g of x equation in the f of x equation for every x value. So typically we're used to plugging in a number in for x, like -2 in the last example, which then changed to a -3. Okay, but in this case we don't have a number to actually plug in, we have a function to plug in. So can we think about what that would look like if we were to take the g of x equation, 2x plus 1, and we were to put it in for every x in the f of x equation? Can you think about what that would look like? Okay, instead of 2x, we're going to replace that x with the g of x equation, 2x plus 1. And instead of the other x, we'll replace the same quantity. Does that make sense? Do you see how instead of plugging in a number, we're plugging in an equation or an expression? Okay. So we're going to try to simplify from here. We're going to get rid of all the parentheses, try to combine some like terms. What do you guys feel like doing? What do you think, Tori? All right, so we have a power of 2. That means we're going to write this quantity twice. And we're going to go through the FOIL process. Maybe at this point we can distribute in the -3. That's one less thing we'll have to do later. All right, so let's go ahead and do our FOIL process. We're just going to multiply the two parenthesis quantities together. We have 2x times 2x, so that's 4x squared. 2x times 1, another 2x times 1, and then a 1 times a 1. But if you notice, after we get done multiplying those two quantities together, we still didn't really do anything with that 2 out front. Okay, so again, we're going to have to distribute that in to get rid of that 2. And now that all the parentheses are gone, let's go ahead and see if we can combine some like terms. We have an 8x squared, but are there any other x squared terms? No, so that one's going to stay. We have a 4x term next. Do we have any other x terms to use? Yep, we have another 4x, so that we're up to 8x right now, but then we have to take away 6 more x's. So it looks like we're just left with 2. And then we have the numbered terms. So 2 minus 3, we're left with negative 1 plus 2. Looks like we're left with 1. So this is a composition. Okay, we were combining two things together in some method. In this case, we were plugging one function into another one. But notice how we're left with an expression. We have variables left over, not necessarily a number value like all the other ones we've been working with. Okay, so you can work or you can compose function values where you get numbers, but you can also compose functions themselves and be left with equations. Okay, there's two different kind of outputs depending on what you're working with. Yeah, Maddie?
Did you have combined the like terms before you distributed it?
Sure, maybe you did 4x or 2x plus 2x and got 4x, like right there. And maybe you did the negative 3 plus 2 to get negative 1. That's fine. Okay. Yep, there's more than one way to do it, okay, depending on what you feel comfortable with. But you should still get the same result in the end. Did it work out for you when you did that? That's fine, yeah. Okay, so we got to be careful. Notice how we were not working with a number as the x value, so we should not be left with a number as the solution, okay, or as the answer. We might be left with some x's in our final answer. Okay, let's check something neat out. Okay, use the equation you just found, so this 8x squared plus 2x plus 1, to find f of g of negative 2. Don't we already know what this answer is? Didn't we do that up here? We said it should be 29. Okay, let's see what happens here. If we were to plug in negative 2 into the equation we just found, let's see what happens. Negative 2 squared, we got 4. 2 times negative 2 is negative 4. We got 32 minus 4 plus 1. Looks like we're left with 29. Coincidence? I think not. Okay, so you kind of have two methods here. Notice how the one we were discussing yesterday is where you take that input value for x, plug it into one equation, then you take that answer and plug it into the other one. I'm assuming that's the one or method that you guys are going to be most familiar with. But you could also compose the equations first. And then once you have that kind of composition equation, plug in that number in here. Okay, it's a different process. It would still give you the same answer, but notice how it's just a different approach depending on what you're comfortable with. Okay, so what we're going to do today is practice composing these equations. Okay, we might not necessarily be left with numbers anymore. We're going to be left with expressions. Okay, some variables are still going to be left over. All right, so we have 4 functions at the top. I think those are actually the same ones that we were using from yesterday. If you take a look at A, we're going to compose the G and the H equation. What is that notation telling us to do? Can you tell but based off the way it looks? Yeah. Okay, so let's find the H equation, which is our kind of third one listed. And we're going to take that equation and plug it in for every x in the G equation. Now there's only one x in there, so that's kind of easy for us to do. We only have one replacement to show. So we have 1 minus 2, and then instead of writing x there, we're going to replace the x with the H equation. Can we simplify? Can we get rid of some parentheses, maybe combine some like terms? If we were to distribute in the negative 2, Notice how initially the 2's would cancel, one's being divided, one's being multiplied? Yeah.
Could you, like, do 1 minus 2 and then distribute -1? Or do you have to distribute that?
No, because if you think about your order of operations, okay, this is technically multiplication, and that comes before subtraction. Okay? So we have to do the distribution first. If we were to distribute in the -2, the 2's would cancel. One's being divided, one's being multiplied. So we're just left with that -3x. And then -2 times the other -2 would give us the +4. So now that the parentheses are gone, we can combine some like terms. Looks like 1 plus 4 will be left with a 5. So there's our composition. We were no longer plugging in numbers for x. Now we're plugging in expressions. Okay, things with variables in them. Can we take a look at B? Think about what that notation is asking us to do. What do you think? Yeah. Alright, so we're going to take the F equation and we're going to plug that in for every x in the G equation. Again, there's only one x, so that kind of makes our process a little easier. So we have 1 minus the 2, and then instead of writing times x there, we got to multiply by the F equation. Let's go ahead and simplify, get rid of parentheses, combine some like terms. We have to do that distribution first. So multiply in the -2. All the parentheses are gone, so let's take a look at some like terms. We can only combine the 1 and the 10, so it'll give us 11. We doing okay? All right, these are a little bit more kind of involved because we're no longer plugging in numbers, we're plugging in expressions. And that kind of causes us to simplify or use some algebraic properties like, please excuse my dear Aunt Sally, those order of operations and things. Okay, a little bit more involved. Let's take a look at C. What's that notation asking us to do? Go, Marie?
It's asking you to place the x in the F equation of the G equation.
Alright, so we're going to take the G equation and plug it in for every x in the F equation. Looks like we have 2 of them to replace. So we're going to keep the negative. Instead of the x, we're going to replace it with the G of x equation. We're going to keep the power of 2, keep the +3. Instead of the x, we're going to replace that again, and we keep the -5. Okay, we're just replacing the x's. So now let's try to simplify. Okay, order of operations, get rid of parentheses, combine some like terms. Looks like we have a power of 2, so we can write that quantity twice. If we keep moving through our simplification here, you could distribute in the 3 at this point. One less thing you got to do later. Where do you guys want to go from here? A lot of different things you could do. Good, Marie?
Question.
Sure.
But the 2 equations in parentheses cancel out because the one with the other.
They wouldn't cancel out because they're being multiplied together. If they were being divided, they would. Okay, but they're not going to cancel out. What do you want to do? Yeah? Okay, so let's multiply those 2 quantities together. We're not doing anything with the negative just yet, okay, so it has to stay there. Let's go ahead and multiply those 2 quantities together through our FOIL process. Let's see, 1 times 1 is 1, 1 times -2x. 1 times another negative 2x. Negative 2x times another negative 2x is a positive 4x squared. If we continue through what we have so far, maybe you want to combine some like terms like Maddie was mentioning earlier. Okay, you can keep working through it. We have a 3 and a minus 5, so that would leave us with a negative 2. Almost there. We still have another set of parentheses to get rid of, so we can distribute in that negative. Changes all the signs. And maybe now that all the parentheses are gone, we'll combine our like terms. If we start off on the very left-hand side, we have a negative 1. And if we look for any other numbered term, looks like we have a negative 2 on the end. So negative 1, negative 2 gives us a negative 3. Next we have a 2x and another 2x, so that's 4x. And towards the end we have a minus 6x, so that would leave us with negative 2x's. And we have just the minus 4x squared term left over. So there's our composition equation after we put the g inside of the f. We doing okay? All right, let's try another one. What's that notation telling us to do? Part D. Good, Marie?
In the p of x equation, replace the x's with the g of x equation.
There we go. All right, so we're going to take the g of x and plug it in for all of the x's in the p equation. We have 2 of them. So we're going to have 1 minus 2x, and then the plus 2, that's still in the p equation. And then down below we have another 1 minus 2x, and the minus 3 still left in the p equation. All right, let's combine some like terms. We have a 1 plus a 2 in the numerator, so that would leave us with a 3. And down below we have a 1 minus a 3, which would leave us with a negative 2. Can we keep going, or do you think we're done? What do you think, Rebecca? What do you think, Tori?
No, I'm confused. How did you get 3 minus 2x? I just missed it.
Up top,
Yeah.
we have the 1 plus the 2, which gives us a 3.
Okay, so you just
Combine like terms, okay? So Rebecca's right, we cannot go any further from here. Some of you might be thinking, well, I should be able to cancel out those negative 2's and those x's, right? Because technically one's up top and one's down below. But that's not how cancellation works in division if you are subtracting or adding things together. Okay, for instance, just as an example, if we had 3 plus 4 over negative 2 plus 4, because don't these two things match, right? So I'm kind of showing you here how these two things match as well. We know this should be 7 over 2, right? If we add the tops and add the bottoms together, 7 over 2. But notice how if you think that these should cancel, we're left with 3 over negative 2. Is that the same as what it should be? No. Okay, so you cannot cancel things out if they're being added or subtracted together. The only way you can cancel terms out of division is if they're being multiplied. So for instance, if we changed this to 3 times 4 over negative 2 times 4, this would be 12 over negative 8, which simplifies to 3 over negative 2. Do you notice how, if these are being multiplied, you could cancel the 4's then? And isn't 3 over negative 2 the same as 3 over negative 2? Okay, the only way you can cancel with division if things are being multiplied together, not being added or subtracted. Okay, that's a common mistake I see kids make all the time. And I'm sure it's going to happen again this year. Okay, but we're going to see other instances that we're going to have to be aware of where they do not cancel. So just as a little warning, okay, be aware of that. Okay, let's go ahead and take a look at E. find an equation for negative 6x times h minus f of x. What do you feel like doing? What do you think that notation is telling you to do? Go ahead, Maddie.
You have to plug in the equation for each x and then
There we go. All right, so we're going to keep the negative 6x, and that is being multiplied by h of x. Do we know what h of x is? Go ahead, Maddie.
there 2x minus 2.
There we go. That's from the top, right? Okay. So we have negative 6x times the h equation, and then based off the notation, we have to then subtract the f equation, which is at the top again. Notice how I'm using parentheses to show that I am replacing something or substituting something in. Okay, so let's get rid of some parentheses, combine some like terms. Let's see what this composition function looks like in the end. If we were to distribute in the 6x, let's see, negative 6 times 3 would give us a negative 18, but then we have that division of 2, so we'd be left with a negative 9. Then we're also multiplying the x's together, so that would be an x squared. If we distribute again, negative 6x times negative 2, we got a positive 12x. If we keep moving through our expression here, if we were subtracting f of x, that means you're subtracting every single term from the f of x equation. So we have to distribute in that subtraction or that negative. It's going to change all those signs. So now that all the parentheses are gone, let's go ahead and combine some like terms. Negative 9x squared, positive 1x squared. So we're left with negative 8x squared. We got a 12x minus a 3x, so that would be a 9x. And our number value left over looks like it's just 5. Are we doing okay? Are we getting used to kind of interpreting or understanding what a question's asking us to do based off the way it looks? All right, let's take a look at I. What do you think this notation is telling us to do? Ashlyn, can I come to you for this one? They're going to equal each other, just like you said before. Okay, so we're going to set the f equation equal to the g equation. You can find those at the top of your page. And there's a little bit more to this question. So not only do we want to set them equal to each other, but we want to find out those values of x. Okay, so we want to solve for x. What do you guys feel like doing? Anything popping out at you? Kind of a hint as to what you should try? What do you think, Maddie?
Then add 5 to both sides and subtract 1.
Okay, so let's combine some like terms. Do you want to move the 5 or move the 1? Doesn't matter.
Move the 5.
You want to move the 5 over? Okay. So that would leave us with a 6 on that side. Okay, we can start to combine some like terms. I like that. Anything else we can combine together or start moving around? Good, Marie? Why? It's a quadratic. You see that power of 2 in there? Okay, it's a quadratic equation. If it's quadratic, we could try to factor it, okay, get those little groups to help us solve for x. And if we're going to try to factor, we need our equation equal to 0. So you kind of got to pick which side you want. Do we want to move the left side over to the right or the right side over to the left? What do you want to feel like doing? Yeah.
We want to move the left one to the right to move x.
All right, I like that analysis. Do you notice how the x squared term is negative? Okay, it's usually easier to factor if that's positive, okay, because you want it to kind of fit, if possible, that I am format. You kind of want a positive 1. So let's move the left-hand side over to the right to make this a positive x squared. Okay, so if we move over the negative x squared, it's going to become positive. If we move over the 3 by subtracting, we're going to be left with a negative 5x, because we already have a negative 2 on the other side. And we're just left with the positive 6. All right, so we have a quadratic equation equal to 0. Let's go ahead and try to factor. It fits that I am profile. Can we think of two numbers that multiply to 6 and add to negative 5? Little mind game. Yeah. Negative 3 and negative 2. Works for me. So if those are the factors, what are our solutions? Yeah.
3 and 2.
3 and 2. Perfect. All right, really nice, guys. Really, really nice. Let's take a look at F, kind of skipping around a bit. What do you think that notation's asking us to do in part F? Go, Marie.
Multiply the f of x equation and then cube it.
Okay, we're going to do some multiplying together. So the F equation is at the top. And we got to multiply that by the G equation. How do you guys want to get rid of those parentheses? It's not necessarily FOIL, right? Because isn't FOIL when you have like 2 terms times another 2 terms? First, outside, inside, last. This one's a little bit more involved because we have 3 terms times 2. What do you think? Yeah.
We need to multiply the first equation by 1 and then by negative 2x. We'll combine it.
And then we're going to combine. Okay, so we're still going to do distribution, but it's kind of like distribution on steroids. We have a lot of distribution to do. So Marie was saying you can either take these 2 terms from the g of x and distribute those in, or you could take these 3 terms from the f of x and distribute those into the other quantity. Do you have a preference which one we use? It doesn't matter. It's going to work out the same way. Yeah. You want to go? Okay. Yes.
It's for you.
It's for me? Thank you. All right, so let's go through some major distribution here. Okay, if we take the 1 and distribute in, let's see, we'll start over all the way on the left-hand side. 1 times negative x squared is a negative x squared. 1 times 3x is a 3x. 1 times negative 5 is a negative 5. Now we still have to do the same thing, but distribute in the negative 2x. So negative 2x times x squared is a positive 2x cubed. Okay, you have 3 x's. Negative 2x times 3x, so negative 6x squared. And negative 2x times a negative 5 would be a positive 10x. So it's not exactly FOIL, but it's very similar. You just keep going through the distributions until you have all of your possibilities. So now that all the parentheses are gone, let's go ahead and combine some like terms. We have a negative x squared and a negative 6x squared later on, so that's negative 7x squared. We have a 3x and a 10x, so that would give us 13. We have a negative 5, but no other number value, so that'll stay. And we have a 2x cubed, but no other x cubed to match it, so that'll stay as well. Now, some of you might be used to like putting your terms in order, like the x cubed, and then the x squared, and then the x, kind of like that. If you want to reorder them, that's fine. Or if you want to leave it like that, that's okay too. Okay, it's just a personal preference, whatever you feel like doing. Are we hanging in there? Okay, we're composing function equations. No numbers this time. We're left with variables. All right, let's check out our last one. What is that notation asking us to do? Go ahead, Maddie.
Take the g of x equation and add it to the p of x equation.
All right, g of x equation plus p of x equation. Hi.
Do you have this person in here?
I do.
Okay. Samantha gave us a Should we want?
All right, so let's take a look at this. This one's a little tricky. Okay, notice how we have this quantity, the 1 minus 2x, plus this fraction. Okay, so we're going to have to dig deep for this one. If you're going to add a fraction, or aka add fractions together, what has to happen? How do you add fractions? Yeah. You need a common denominator. Okay, so can we think about what is the denominator of this 1 minus 2x pair? Yeah, it's 1. Okay, so you can, if you want to, go ahead and think about drawing your division line and putting a 1 there. So when we look at this right now, we have our first fraction plus the second fraction. We need to get a common denominator. Right now, the more complicated denominator is that x minus 3. So how can I change this denominator of 1 into an x minus 3? Yeah. By x minus 3. Perfect. All right. How do you multiply fractions? Because right now we have on the board we have these red items being multiplied by this fraction. How do you multiply fractions? Any ideas? Yeah? That's if they're equal to each other. If you have two fractions equal to each other, you can cross multiply. Yep, multiply straight across, okay? So if we take this x minus 3 times the 1 minus 2x, we're going to go through a FOIL process, right, to get rid of those parentheses. X times 1 is x. X times negative 2x is a negative 2x squared. Then we have negative 3 times 1, and then negative 3 times a negative 2x would give us a positive 6x. All right, so then all of this is now over x minus 3 times 1, which is just x minus 3. So now that we have a common denominator, let's actually go through the addition. How do you add fractions? Now that the denominators match, how do you go through the addition? Is it like multiplication? Do you add the tops, add the bottoms? What do you think? Yeah. Well, you add the like terms up top. Not quite. Let's see, if we think about 1/2 plus 1/2, we know that should be 1, right? Let's see, 1 plus 1 is 2, and in order to get our answer of 1, we'd have to keep the common denominator. Okay? So we're going to add the like terms in the numerator, but we're going to keep that common denominator. So if you look at all of your top pieces there, we have an x, we have another 6x, so we're up to 7x, and now we're adding another x, so that would leave us with 8x. The next term is a negative 2x squared, and we don't have any more of those, so that one can stay. And our numbered terms, we have a negative 3 plus a 2, which would leave us with a negative 1. So after we add all those like terms, we're then going to keep the common denominator, which was that x minus 3. Can we cancel anything out? We're shaking our heads no. That's good, because things are being subtracted or sometimes added together. Okay, so it has to stay like this. That one was a little involved. We hanging in there? We doing okay? All right, so today's focus was still composition, but composing equations together, okay, not necessarily number values. All right, so tomorrow we're going to go ahead and dive into the next section. Tonight, go ahead and try maybe some of those homework problems. If you take a look on page 71, you're given a graph, a table, and an equation to use, which we've dealt with all of that already. And you're going to use those pieces of information to kind of fill out this chart and make some comparisons. The back page is very similar to what we did today, okay? Taking some equations and composing them together. I think you guys are going to do very well. All right?